I'm Tom Enebo.
And I'm Charles Nutter.
We work on the JRuby project, and we're also employees of Engineer. So the goal for today is to learn enough about JRuby internals to maybe by the end of the day start working on your first JRuby bug. But JRuby 1.6 is going to be going into RC around December 10th-ish, and hopefully by Christmas we'll have a final release of that. It has two big features. One, we're going to finish 1.9 support, and it's in fact even going to be in mixed mode with the JIT.
Yep.
And so it'll have great performance. And we're going to start dogfooding Windows more. All these execution bugs that we've been fixing made us realize that we probably need to be on a Windows box more.
Now, also since last year, things have been going well for JRuby. We've had 2 JRubyConfs. We had one attached to RubyConf last year, and then a standalone conference in Columbus just a little over a month ago. And lots of folks are starting to take notice and start to actually adopt JRuby, so we're pretty happy how things have gone this past year.
We spent over 2 years now working on this book with 5 people, so we're going to flog it every chance we have. But it is actually a great book. It covers pretty much every topic you could want to know about JRuby, including some portions of today's talk on hacking, or at least making native extensions. There's a URL. Please buy it. It's not actually out in print form yet, but you can get the electronic version now, and then they'll mail you the print version. If you're actually going to hack on JRuby, you actually need the source code. So we recommend getting it from GitHub. It's not our actual normative source for the source code, so it's like a half a second out of date. But it's better for you to actually clone from GitHub so that you can fork it and send pull requests and stuff like that. And all you need to actually build JRuby is Java, which how many people are actually on Windows boxes here? So very few. You'll have to download Java, but for everyone who's on a Mac, Java's already on it. And if you install Xcode, you'll get and if you're on Windows, you'll have to download it again. But once you have those two, you can just type and. You'll see a bunch of text churn by, and you'll compile JRuby. Edit a file, change one line, type and you've just hacked JRuby. Most people when they get started, probably 85%, end up scratching their own itch. They'll go and file a bug on our bug system, and then we won't have fixed it for a week, and then they're like, I'll just fix it. And they do. So obviously, if you filed a bug, there might be good motivation this afternoon for you to fix it. But when I started on the project, I wasn't actually using JRuby for production. I just thought I would teach myself Ruby by working on implementation. So I actually scoured bugs and just started trying to help based on the bugs that were reported. So that's a fine way to get started.
And actually with our hope to have at least solid 1.9 support in 1.6 within about a month, that would be a great area to help out. So you can take a look at what specs we're passing, what bugs have been filed against 1.9. We've actually got a bug category for 1.9 bugs, and that would be a great place for you to jump in and help us get it finished up.
And don't have fear. Anytime you go and look at a new code base, it's always a little scary, but trust us, after a day or two, you'll love it. And Java is easy, but we'll be talking about that in a little bit.
So I wanted to mention this. This is an announcement that just came out today. A lot of folks have asked us repeatedly, endlessly, about what we think the Java deprecation on Mac OS X is how it's going to affect Java, and is this the end? Is it all over? Java's dying now, finally? Well, no. I think that's a little bit overstated. And in fact, this announcement now, Apple has announced their intention to contribute to OpenJDK 7 for Java 7 to have it solid and work just as nice as the Java they have now on macOS. And they've also said that Java SE 6 will continue to be in future releases at least through line. So it's not going anywhere, and again, you're not going to have to worry about having Java on Mac. All right, so the first thing that a lot of people do to try and figure out something they want to work on, if they want to just dive in, or if they've got problems, is using some of the various tools and tweaks and configs that we have in JRuby to investigate problems. And I want to start out by talking about some of the basic config flags. I'm not sure we've ever actually had these on a slide, but useful stuff to have. So of course, -H will show you basically everything I have here. But one of the first ones that you might have to deal with is, as far as tuning JRuby, is adjusting the maximum minimum size of the heap, adjusting some of the JVM settings. Anything that you can pass to whatever JVM you're running on, you can just append to a -J flag, and it'll actually pass it straight through to the JVM. So you can make all the tuning adjustments that you need that way. There's also Java opts, which will pass on directly to the JVM as well. There's also some internal properties in JRuby that can tweak JIT settings, that can tweak whether you're allowing native code to run, things of that nature. -- properties will show all those. I've got a couple examples on the next slide. And then there's a few JRuby runtime flags that are common enough. We've added special shortcuts like -x-c to turn off the JIT. It's a good way to investigate whether a compatibility problem might be a JIT-related issue or an interpreter-related issue. Then there's a few others. -x+o will turn object space on. It's normally off in JRuby, or it doesn't have a full complement of features. And again, all of these can also be passed in through JRuby opts as an environment variable. So as far as tweaking the execution of JRuby, of course there's the --19 flag, and probably for the foreseeable future that will be the flag to turn on 19. If you want to run in 19 mode by default with JRuby 1.6, you could just put that in JRuby opts, and it would be set up and use it all the time. A few interesting properties. Sometimes there's an issue with a native library. Maybe it's causing something to crash. Maybe you want to see if it's, make sure that it's going to run in a more restricted environment that doesn't allow native code. You turn the native enabled to false. Some settings for JIT, depending on what your tuning characteristics for your application are, you may be able to adjust that up and down, change the amount of calls that are required for a piece of code to compile into JVM bytecode and so on. And of course, like I said, there's hundreds of JVM options that are also execution tuning. You could probably write an entire book just on hotspot and all of its flags. A few more just for logging and tracking information about what JRuby is doing internally. You can turn on various levels of JIT logging. The first one will actually show you what methods are being compiled, or were successfully compiled. The second will show you methods that failed to compile. So if you have, say, a performance problem and perhaps the JIT's failing, or perhaps the method isn't JITable by what we have in the current compiler, you'll be able to see that and then know that maybe your code needs to change or maybe something needs to be fixed in JRuby. You can also have JIT dumping turned on in 1.6, which every time it compiles a method, it'll actually dump out all of the JVM bytecode for it, and you can use that to investigate problems as well. There's also a -- bytecode flag, which takes whatever the immediate script or -e line is and shows you what it's going to be compiled to right before it executes. Okay, so the other half of finding problems is just taking advantage of the tools on the JVM. The JVM has been around for 15 years, and during that time, the state of tools has just gotten better and better. As a result, the JVM has pretty much by far the best set of tools, depending on which implementation you're on, of any managed runtime that I know of. And we inherit all of that. So all of those tools work just fine with JRuby. Sometimes they don't, they're very Java friendly, but they may not know specifics about Ruby. But they do an excellent job of profiling, memory monitoring, all the things that you really want to have for an application to remain stable and to be able to keep an eye on it. It all works great with JRuby. Profiling, debugging, memory inspections, of course, and lots of different options. So it's not even just one tool, there's dozens of options that all have their own special characteristics. One thing I want to show real quick before we get into the hacking and internals stuff is JVisualVM. We've shown this a little bit in the past, but it still seems to be a tool that people don't realize is actually there. If you have Hotspot or OpenJDK installed, it comes with VisualVM. The command is JVisualVM. Starts up a graphical console that will allow you to basically monitor any JVM process, including JRuby instances, for CPU, memory profiling, and so on. So you get a display kind of like this, and You can see what CPU is doing, monitor individual JVM processes, CPU usage. You'll also have a graph on here that says whether it's spending a lot of time in GC. You can monitor the state of the heap, how many objects are being created, when the garbage collection is firing. If you see a nice sawtoothing system like this, you probably have a good system. If it's continuing to go up, or the peaks always seem to get a little bit higher every time, probably some sort of memory leak that you need to worry about. There's also a possibility of heap dumps and browsing the object heap. I'm going to actually show this live in a second. Okay, here we go. So this is always more fun to show live. So I have a command I ran here, constructed a class foo, and then it's like 10,000 times appended foo into an array. I'm also passing a special flag here to JRuby that actually makes the foo class turn into a Java class right before construction, so that it'll show up in normal heap profiling and memory profiling tools. So now here is actually a live view of what objects are in the system. And of course, there's classes and strings. Pretty typical to see lots of those up on the top of the profile. Lots of character arrays with all the strings that are there. But you can actually see there's this ruby.foo. This is the class that was generated in JVM bytecode for the foo class. And right over here we see we've got 100,000 of those instances. So you can use flags like this and any of the JVM tools to just dive right in and figure out what sort of objects are available, what might be leaking, and several of them actually go farther than this and show you where things are being allocated and do leak detection and say, okay, you've got a big box of objects sitting here, maybe you don't intend that. So lots of great tools, and JVisual VM is probably the first one that I go to as far as doing some memory inspection, or then some amount of profiling too. Okay, back in here. We also have added a built-in profiler. The Java options sometimes are a little cumbersome to work with, and we know a lot of people who wish to work on a command line. So JRuby 155 Plus also has a -- profile flag that is Ruby specific. So you get some output like this. Here's running the Richards benchmark, and you can see the schedule method is up on top, taking up the most time, and then it goes on down from there with the other Ruby options. So both the nice graphical, fancy GUI tools and a lot of command line tools that are available from us and from the JVM. And like I mentioned, there's also a lot of third-party tools. YorkIt's probably one of the nicer commercial profiling setups. JInsight is a commercial profiler that actually has JRuby specifics in it, so it can track objects and Ruby method calls along with tracking Java stuff. Eclipse Memory Analyzer is my go-to tool for investigating leaks. And that's actually a free one that you can download and give it a heap dump, and it'll tell you where leaks are. It'll let you walk through the objects, and makes it much easier to investigate memory issues. All right, so on to extending JRuby, the interesting stuff. So there's really two ways that we recommend that people do this. The first one is generally just write Ruby code. You can call any Java library and pretty much just pretend like it's Ruby. And JRuby's core is actually 100% introspectable as well. So if you want to investigate problems from IRB and poke around JRuby's internals, that's possible too. I'll show an example of that in a moment. The other way would be to write Java. And Tom will talk a little bit about what the actual structure of Java extensions are, how they fit into the system, and how you can start writing them today. So Java integration, there's really only a few key things. Require in Java, you can pull in some extra jar, which could be an arbitrary Java library. Import the classes and then pretend it's Ruby. It ought to work and feel just like it's Ruby for almost every case. If it doesn't, there's something that we're doing wrong. So you can use any libraries that are out there. And a quick example of this is actually kind of from Yoko's talk yesterday. We've shown lots of Java integration examples, and there's plenty online, so I just wanted to show a couple quick ones. Here we're actually taking JRuby's scripting container, which is our embedding API, if you're going to call into JRuby from Java, and importing it into JRuby, and then calling it to start another JRuby instance. So you can do things like this, actually spin up JRuby instances within JRuby instances, and do it all entirely from Ruby. Now the wilder stuff is when you pull in the JRuby library, require JRuby. You can see here we've got a string, which the class is string. It's got 80-some methods. But if you use this JRuby.reference, what it actually does is take that Ruby string, which looks like a normal Ruby string, and says, here's what the Java view of that object is. All the Java methods are there. You can see there's 982 methods on here. Some of those are aliases of others, but basically everything that's defined on our Ruby string class in Java is now accessible. And you can start poking around the internals of JRuby itself. Now, a more entertaining example is the dreaded object become. Here, actually implemented entirely in Ruby, because we can go into the internals of JRuby from Ruby code and start tweaking things. So here I'm adding a become that changes the meta class for a particular object. So we have class foo, we have class bar, and then down at the bottom we actually change foo into a bar. All from Ruby.
It's so wrong.
It's so wrong, but it shows you that you can actually get at this stuff. And JRuby is probably the most introspectable of any of the Ruby implementations, simply because everything is just a Java object at some level, and it's all available from Ruby code very easily. So the perils and pitfalls of doing Java integration-based extensions. There is some overhead when you call from Ruby into Java and when objects come back from Java into Ruby. String is an especially difficult case. Because Java strings are all UTF-16 character arrays, we have to convert Ruby strings up into UTF-16. When they come back to Ruby, we convert them back down into UTF-8 or whatever your current encoding is. So that can be a problem. You can avoid some of that by pre-caching the coerced strings, but it'll eventually start to bite you if you're doing a lot of strings and a lot of fine-grained calls across that boundary. There is also overhead just from the fact that we're wrapping other objects. Every Java object that comes into Ruby needs to get wrapped with a little pseudo Ruby object wrapper. And those wrapper objects, since we want to be able to do instance variables and singletonizing of Java objects, etc., those actually are held in a separate weak structure. So that can end up adding extra overhead just because we want to maintain the identity of those wrapper objects. There's, of course, overhead from using reflection. JRuby primarily uses Java's reflection APIs to call into Java from Ruby. That adds a little bit of overhead as well. And of course, there's always little dusty, unoptimized corners of JRuby. We've improved release on release, lots and lots of Java integration stuff and the performance of calling from Ruby to Java, but it's still always a little bit of work to be done. All right, so now you might ask why you would want to use Java to do extension. And is this where you've taken over or what?
No.
This slide came out of order a bit. Oh, right, 1 minute apps, got it. Okay, so now after you've played around with doing it from Ruby, you may want to actually get some of the performance, typing, whatever guarantees of writing in Java. And why would you want to do this? Or at least, why would you rather do this in Java than in C? And when you look at it, really, Java is a much closer fit to implementing Ruby than C is. It has a GC, so you're not doing memory management, you're not doing pointer logic. It's single inheritance language. It's VM-based. I mean, we have segfaulted the JVM, and we can do that. What causes those segfaults? It's when we call out to C. It's always the C thing. It ends up blowing up stuff. So writing in Java is going to be a much cleaner experience, at the very least, for hacking on JRuby.
So can we get a hands raised for how many people know Java?
Wow. Sweet.
Okay.
So this is going to be more like 30-second abs then. Okay. So we want to do a little like Java thing, not really teaching the language, but teaching the structure more. So like it said, it's single inheritance language. Object is at the top of the hierarchy, just like in Ruby. There are primitives also, so it's not quite a pure object-oriented language. But largely this is done for performance reasons. You want to be able to guarantee that you're going to have primitive-level performance than having everything be an object and just praying that the JVM is going to be able to optimize it for you. So you've got signatures for all methods. You just provide the return type, argument names, and argument types. And that varies from language to language, but generally in Java, that's what you do. You can have multiple methods with the same names. You've got overloading. You use interfaces for a multiple inheritance. So rather than object multiple inheritance, you have interface multiple inheritance. Interfaces are basically just a bag of empty method signatures, and largely cleaner to depend on interface types than to depend on the concrete types. So you can swap out what the implementation is underneath. The compile phase resolves all the types ahead of time, so classes are closed, but the JVM is totally amenable to loading additional code at runtime, which lets you get around some of that staticness. And of course, object casting is one of the runtime type operations, actually type checked at runtime. So Java is not Ruby, and we recognize that it's not as nice of a target for hacking as Ruby might be, but it's a hell of a lot closer to Ruby than C is. So it's really not that bad a deal to use Java to extend JRuby or to hack on JRuby internals. Okay?
I'm going to explain motivation.
Oh yeah, explain motivation for weakling. Okay, so we're going to talk a little bit about a simple Java extension. It's called Weakling. It's a gem that's out there. You can gem install Weakling or go to my account, Hedius, on GitHub and find the Weakling project. It's a kind of a nice, simple example of what it looks like to write a JRuby extension in Java. Weakling is a weak reference library. Weak reference is an object reference that does not prevent that object from being collected. So you can use it for weak collections or for lazy operations like that. What this adds over Ruby's weak ref is a reference queue. A reference queue is basically a VM structure you create and you pass it in when you create your weak ref. And whenever that object gets collected and the weak ref no longer refers to anything, it gets pushed onto this queue. And then every time so if you want to do a weak collection, you can say, oh, okay, whenever the objects in this weak collection disappear, put it in the queue, then I'll clean up the collection and get those empty weak refs out of there. It's much more difficult to implement weak collections without something like a reference queue. And it's something that really is missing in regular Ruby. And there are some people that are going to implement this for C Ruby as well. So now, why did I do this? Well, first of all, we had this issue with ID to ref. ID to ref is an internal function in object space that has turned into an external API a lot of people use. ID to ref basically takes the object ID and gives you the object reference that goes along with that. Unfortunately, it is entirely broken for weak ref implementations because that ID is essentially just a pointer location. And since Ruby tries to reuse the same locations in memory, the same positions in the heap, there is a potential that for some amount of, if you don't catch it at the right time, that ID may not just not point to the old object, it may point to a new one that was put in its place. And now you've actually got a completely different object at that address than you expected to have. So ID to ref is not something anybody should ever be using, okay? That's my rule number one about memory and objects and IDs in Ruby. Don't use ID to ref. Memorize weak ref also uses delegate, which is, at least in 1.8, a terribly slow library. In 1.9 it's improved somewhat, and we have a modified version of it that's improved too. And collections, like I say, are very hard without reference queues, so we needed to add that. Java provides native stuff for this also. There's no reason that we need to use the sort of hacky version of weak refs that's in standard C Ruby when we have solid VM level weak refs and reference queues. And so we just wrapped that and went from there. So now again, why in Java? We wanted to avoid the additional Ruby Java integration overhead. We wanted to just be at the Java level and keep clear performance guarantees about how it's going to run, avoid reflection, and have it feel a lot faster so it can be as solid as possible when you're using it for something like a weak collection.
All right, I'll just swap. So this is the first Java code we've seen so far in the talk. It's responsible for bootstrapping the weakling library. It just needs to implement one interface to do that. We'll walk through the actual loading sequence though. When you actually call require weakling, I keep wanting to say weak ref, it ends up burrowing down to load service require, which is a Java method. In turn, load service require uses a heuristic to go and discover this particular class in a jar. It's a little out of scope for today to explain it, but it's a pretty simple heuristic. And then it executes basic load. And now basic load has to go and bootstrap the actual library, and you can see that it's constructing an instance of refq library and then calling load on it. If it's able to load it, it returns true. If it can, it returns false. That makes sense, right? And if something horribly went wrong, then we'll throw an exception. So let's burrow down into the refq library class. The first thing we'll look at is load, because that's where all the bootstrapping is really happening. The first thing you'll notice is all the references to runtime in red. This is a class, org JRuby Ruby. It's our main context class for an individual Ruby runtime. Notice that I say individual runtime. We can actually run multiple Ruby instances in a single JVM. In fact, this is how we implement listeners in Rails when we're not in thread safe mode.
And of course, that also means we run multiple Rails apps in the same JVM. It's really not a very difficult thing. JRuby is just another object in the JVM.
And like a typical context object, it basically holds a hard reference to anything that actually matters. The class hierarchy, then by extension all the live objects in the system, in, out, error streams, finalizers, everything pretty much. But the reason as someone who hacks on JRuby, you're going to see this class a lot is because we have a billion methods on it for retrieving and creating objects. So if you want to get a reference to nil, just call runtime get nil. If you want to create a new fixed num, call new fixed num, and if it's been cached, it'll return a cached copy. But there's lots of useful methods on Ruby, the class versus the language. So if we actually look at the load method now, the first thing we do is we require weakref. This is so that weakling can get access to the ref error class in weakref, so it tries to go and be compatible with weakref in such a way that you can swap this out and your calling code will still basically be the same.
This library was written to work with existing versions of JRuby at the time, which meant that we wanted this to load as an extension but still fit into the same API and the same structure of the standard Ruby weakref library. So it pulls in that weakref library and then essentially just replaces some of the classes.
Next, we go and ask the runtime to get or create a module. In this case, it's a new module, so it constructs that new module by the name of weakling. If we go down here, next we define a class called weakref, whose superclass is object. It has a weakref allocator, which I'll talk about in just a minute, and it's defined underneath the weakling module. So, you know, weakling : weakref. Ref queue is more of the same. So, if we actually look at the weakref class, the first thing you'll see is, weakref extends Ruby object. And so you'd naturally think that that was that relationship in Ruby as well, but it's not quite true. From 2 slides ago, we showed this define class under method. This is where all the Ruby relationships are happening. We have a set of methods for establishing every Ruby relationship you have as Java methods, but we actually have weakref extend Ruby object as a Java implementation convenience. So now if weakref wants to actually do dynamic dispatch, well, Ruby object implements a call method, again, another tongue twister, but now it has access to all those methods and that additional state. So it's just an implementation convenience.
It's kind of it's one of the more confusing aspects when you start hacking on JRuby is the fact that there are these 2 hierarchies. You can think of the Ruby hierarchy as the dynamic dispatch hierarchy, and the Java hierarchy as the static dispatch hierarchy. And then we put those 2 together, and we get Ruby objects and Ruby's structure.
And if you're confused, everyone gets confused by this for the first couple days. So one line I didn't mention in the load method was for weakref, we called define annotated methods and then passed in a reference to a class. What this does is it scours the class for @JRuby method annotations, which specify all the Ruby methods that are defined in this weakref object or type. And then this is how we actually bind the Ruby name to Java type signatures.
So if you've ever done a C extension, this is equivalent to what you have in your init method when it goes and creates the classes, and then you see define this method pointing at this function, define that method, and so on. We don't have those calls. We just have this nice syntax for saying this Java method, bind it so it can be seen from Ruby.
That's right. The arguments that you pass in are important. If you see weakling's initialize method on weakref, it takes an object and accepts an optional queue argument. If you actually look at the initialize method in Java, we actually specify a primitive array of args. So we elected to go and receive the arguments, figure out if we have the right arity, and set up the right default value. I'll talk about allocation. Remember back in load, we specified that there was a weakref allocator. There's the Java code in its entirety. Let's just walk through the allocation sequence. So when you actually call weakref.new, that in turn calls allocate. Allocate then goes and asks for what the allocator is, and there it is. So it executes the allocate method, which then constructs a new instance of the Java weakref class. And if we actually look at that constructor, it's actually not doing a lot. It's calling the superclasses constructor, but it also has a ref field, so it is actually initializing the ref field to null. So it's setting up internal state. So you could, if you had another class, you could see that you could initialize values.
And actually, if you look into Ruby object or Ruby basic object, you'll see that eventually this class that's passed in gets set into a meta class field into the object. So largely for internal state that doesn't come in from initialize.
If you want to have a fun journey, start up at Ruby class and just follow the constructors all the way down. It's a road less traveled. So
here we actually move on to initialization of the object. Yeah. This is actually the initialize method that would be seen from Ruby.
So after allocation happens, then new calls initialize, which then executes this code. That ref field that I said was nulled out now gets replaced with a Java weak reference type, where the first argument passed in is actually the object that you want to have a weak ref to. And we return nil because that's what you're supposed to do with initialize. And that's what I just said. So, in fact, if you check out weakling source code, you'll see that we didn't actually use a primitive array of arguments. We actually have it split out as two separate Java signatures. So this is actually quite convenient. By virtue of actually having two different initialize methods in Java, now if you go and call weakref.new with one argument, obviously calls the first one. If you call it 2, it calls the second one. But what's even better is if you call it a 0 or 4, it just throws the appropriate error. So we now have been able to get rid of this extra arity checking from our code. And more importantly, we're no longer boxing arguments. So we're not creating a primitive array and then populating that array every time we make the call. So things actually run a little bit faster.
This is actually some of the nice magic that we get from using these annotations to bind all the methods. At binding time, it goes and inspects the signature of each of those and says, oh, do they want a thread context passed in? Do they want to receive a block? Do they have one argument, two arguments, variable arguments? And then it just makes it all wire up properly. And the effect of this is that when you write in Java, write the Java extension, it actually doesn't even have to do any arity checking. So you go straight through. If you're passing two arguments, it knows straight in. It takes two arguments, goes all the way there. It makes things that end up running a little bit faster than having to do an extra Boolean check to see whether you've got the right number of arguments or not.
And there's a few additional things you can do. Charlie's talking about that auto wiring. Sometimes it's convenient to actually have another internal class called thread context. This gives you access to things like the call stack or backtrace information and stuff like that. In this case, we're actually using it for Git runtime. But for any bound JRuby method, you can just put this as the first argument, and we just magically hook it up and provide you with the thread context. Likewise, if you have a signature that might require a block, you can just add a block variable at the very end, and we'll just pass the right thing to it. So the auto wiring of JRuby method really cleaned up our code a lot.
Actually, one thing you'll notice here, we're calling block is given without doing any null checking or anything. JRuby for blocks uses a null object pattern. So if it is not a block that was passed in from the user, or if no block was passed in, this will just return false. It'll be the null block that we pass around. So you can always count on that block argument that's passed into your method to never be null.
Do you know if we have an assert in the actual populator code to throw it if we're manually calling the method without a block?
No, not right now, no. But if it calls from Ruby and you pass it with no block, you're guaranteed it will be an object of some kind.
So we just talked about bootstrapping code and how methods are bound. Let's actually look at some code inside the method. Here's the get method. We just talked about that. So you'll ask the Java weak reference to get an object, and that object will get returned. If it's been collected, then it'll actually just return null. And if it does return null, we'll throw an exception. Otherwise, we return the object. So this is pretty easy to understand. But it doesn't actually do anything with types. It doesn't do any coercion. So
another quick note on the annotation there. You notice that name is get, and the Java method is named get as well. If the method, name of the Java method is going to be the one you want to bind into Ruby, you can't omit that. But if it's a Ruby method name, like with a question mark or a bang, that doesn't fit Ruby, you can add that into the name argument for the annotation itself.
Weakref alive is an example of that, by the way. Down towards the bottom.
Right. A question mark is not a valid identifier character in Java, so we put this _p for a predicate, and then name equals the question mark.
You know, I don't like transitions. Okay. Oh, I could have went forward one slide. How fun was that? Okay. If you want to go and create new instances, I mentioned this before, but you can. There's a method for every single core type on that class. So you want to create a Boolean, new Boolean. It's as easy as that. Type coercion, we have a number of type coercion methods, and most of them are named the exact same thing as MRI. So if you've had the C implementation, num-to-lum will look very familiar to you, and it obviously behaves exactly the same. We also have a bunch of convenience mechanisms on Ruby object itself that allows you to ask it to convert to integer, and then it'll actually do a dynamic dispatch to toInt. If you actually want to just do dynamic dispatch, we have a whole series of call method overloads. The top one is a no-arg version where we're just calling toFoo. But if you actually have arguments, you can just add those arguments onto the end of that chain, and you have it up to like an arity of 5?
Yeah, but I think it's also a var. So you can pass any number of arguments into that, and it'll pass it along.
And if you have to call something with a block, you just pass a block as the last parameter. Lastly, you can always just evaluate Ruby code itself by calling eval scriptlet on runtime, and it'll return what you expect.
All right, so we're almost done here. Now, we understand that Java is not necessarily the greatest language to implement a lot of this stuff in, and that's one of the reasons that I came up with Mira. Mira is essentially a language that it uses Ruby syntax, and it looks and tastes like Ruby, but it's just a syntax for writing Java code, a little bit nicer syntax and cleaner. And as a result, you can write something that looks like Ruby and have some of the benefits of writing Ruby, but you get bare metal performance guarantees like writing Java. I kind of think that this might be the future of Java extensions, that we might expect more and more people to use Mira to write these extensions rather than writing them in plain old Java. So I'll show you a quick example of what that looks like. Bring up my favorite editor, Redcard. Okay, so, which is written in JRuby as well, by the way. So here we have the same thing, but implemented in Mira. Now, Mira doesn't quite support this annotation syntax yet, but this is essentially what it will be very shortly. Here we have the initialize method. We have our get method. We have the initialize down. So initialize is actually used both for the constructor here and for the regular initialize. But you can see that this actually ends up looking and feeling a whole lot more like Ruby. The structure of things is much simpler. You only ever have to declare the argument types. The rest of it is going to all be figured out. Here we've got a field. It turns into a regular Java field. And again, it just infers the type from what you're assigning to it. Almost done. Okay. And again, weak ref alive, and so on. A nicer way. Probably in the future, this is what we think most people will be doing for JRuby extensions, especially if you've got a preference for Ruby syntax and some of the nice features of Ruby. Okay, so that's about it. That timed out pretty well. So there's Twitter accounts for all of us. You can also find our emails pretty easily online and send us email. JRuby.org, there's my blog. I blog fairly often. We've also got links from JRuby.org to the other developers' blogs. We have the book, of course. We'd love for everybody to pick it up and let us know what you think. And I guess we have some time for questions. So, who wants to go first? Oh, one way in the back.
So I don't think you just brushed off Mira at the end, but I know it's still the works, but would it be possible for Mira to include existing Java classic libraries? Is that something that works, or is that conceivable?
Okay, so the question was, can Mira use other Java libraries, pull in other Java libraries and call them? Is that basically it? Yes, yeah, absolutely. Mira essentially is just like a replacement for Java C. It's just a language that compiles essentially into Java. So you import Java classes, you have all the same capabilities to call into Java, absolutely normal, and it actually turns into just normal Java code. And in fact, the Mira compiler has a -java flag that outputs Java source instead of JVM bytecode. So it's essentially just a syntax, maybe a source-to-source or a source-to bytecode translator that takes Ruby syntax and makes Java code out of it. So it's not Ruby, but it's a much nicer way to write Java.
We were saying this yesterday. Mira is sort of the coffee script of Java.
Yeah, that's a good analog. Yes, here.
When you're just compiling the Java source, does it require JRuby?
The JRuby, the Mira compiler is written in Ruby. It's about 10,000 lines of Ruby code, so if you want to hack on Mira, please do. Mira.org. It actually requires JRuby at that point, but the resulting class files have absolutely no external dependencies other than what you've wanted with libraries you've pulled in. And that's, again, trying to be a one-to-one replacement for Java C. Source goes in, class files go out, you walk away with the class files, and you're done with your dependencies at that point. Yeah?
The verify classes option is really useful. Is that something to leave on all the time, or is that
The verify classes option, and whether we can leave it on all the time. Ideally, we're going to do some testing with this, but ideally in 1.6, hopefully that will be on all the time. And so all Ruby objects that you construct will just have a Java equivalent and show up normally in the heap. If that doesn't work because of code loading, class loading issues, collisions, and whatnot, we may just leave it as a flag that you can turn on. But it most likely it will be safe. I've run it with Rails and Gems and other stuff, and it seems like it's pretty safe for most libraries and most applications. But it remains to be seen whether we'll have it on by default in 1.6. What have we done? 11:10? I think so. So I think that's about it. You can grab us afterwards, and we'll probably hang out in the hall for a little bit. Thanks very much.